Okay, guys, day before yesterday we learned about resistors in series. Yesterday we learned about resistors in parallel. Now you're going to learn about resistors in series and parallel. And essentially we're just going to learn some techniques for simplifying resistor circuits. Now let me give you an example that I do, then I'll give you guys an example that you do, and then we'll be done. Here it comes. Woo. Here comes example number 1. Okay. Please draw this circuit. This is 220 ohms, this is 250 ohms, this is 180 ohms, and this is 110 ohms, and this is a 24-volt battery.
Watch the trail.
220 ohms. I don't know if that looks like 220. Here, I'll do it better. Noel's back just in time.
Oh, Noel, when you watch his videos, you'll see him say, "Hi, Noel," in some of them.
Oh, for the calculus ones? Yeah. Alrighty, resistors in series and parallel.
Yep.
Okay? We're going to do some simplification techniques. Suppose I asked for the following. Number 1, suppose I want you to get the equivalent resistance that the battery feels. I want the equivalent resistance the battery feels. I'm going to call that resistance R sub EQ. Okay, but you can call it whatever you like. The second thing you're going to get is the current out of the battery. Current out of the battery. The current that the battery delivers, which we'll call I sub bat. The third thing we're going to get is, please designate this point as point A and designate that point as point B. And I'm going to get the voltage drop from A to B, which I'm going to call V sub AB. And then the last thing you're going to get is the current through the 250 ohm resistor, which I'll call I sub 250. The technique for getting all this stuff is actually very easy to say, but in order to get good at it, you're going to have to do lots and lots of problems. This is the type of thing that the more you do it, the more intuition you gain. Here's the simplification technique. Simplification techniques that you're going to be using. Number 1, you're going to start far from the battery. You're essentially starting far from the battery and working yourself toward the battery. And then number 2, you're going to simplify any parallel or series resistors using the parallel or series resistance formulas. So, for example, we're going to start as far from the battery as we can, which means we're going to start over here. Look at the 220 and the 250. What do you notice about the two of them? How are they wired? How many people say they are in series? Hey, good for you guys, because whatever current enters and exits the 220, that very same current enters and exits the 250. And they're holding hands, with one hand. So they're in series. Let me ask you this question. The 110 and the 180, are they in series? How many people say, sure, the 110 and 180, they're in series? Okay, great. How many people say they're not? Okay, Brandon, why do you say that they're not?
Because like one goes straight, the other one goes downward, so like it splits up.
What splits up?
The current.
Beautiful. You guys okay with that? That I don't have a situation where whatever current enters the 110, exits the 110, and then enters and exits the 180, because this current splits up, right? Some of this current goes to the 180 and some of it goes to this branch. This is like a river that splits into two tributaries. So no, they're not in series because he's not receiving the same current as that. You guys okay with that? So the 110 and the 180 aren't in series. But these two guys are. So you tell me, what's the equivalent resistance of the 220 and the 250 in series? Yeah, 470. So what I can do, you'll notice this resistor is attached to this point, and this resistor is attached to that point. I can get rid of those two resistors and replace them with a single 470 ohm resistor. So they're gone, they're out of the circuit. So I've just simplified my circuit. I have one fewer resistors. Instead of a discrete 220 and 250, I just mashed them together to make a single 470. Tell me, the 180 and the 470, what's their relationship? How are they wired? How many people are thinking they're in parallel? Sure. The first way I know is because whatever the voltage drop across the 180 is, this 470 is going to have the same voltage drop. Because this point A, hey, that point A is attached there. This point B is attached there. They're attached via a conductor. You get the same voltage here as here, same voltage there as there. They have the same voltage drop. Another way I know is because they're hooked up. Who was it yesterday who I hypothetically was holding hands with?
Stanley.
Okay, Stanley. So yeah, you see that? Do you see that if my right hand holds Stanley's left and his left hand holds mine and then we dance, you know? Well, the same thing here. His right hand is holding his left hand hand's holding his right hand, right? They're hooked up in series. So what formula am I going to use to get the equivalent resistance between the 180 and the 470? Anyone thinking the parallel resistance formula?
Yeah.
Okay, good. So for the 180, and I'll do it over here, for the 180 in parallel with the 470, I'm going to have to go 180 to the negative 1 power plus 470 to the negative 1 power, quantity to the negative 1 power. Hopefully you're all aware that the equivalent resistance better be less than 180. If I do the punchy and I get a number higher than 180, I know I did something wrong. Because the equivalent parallel resistor, the resistance has to be lower than the lowest resistance. Well, it ends up being 130. So now, because these two leads are attached to A and these two leads are attached to B, I can essentially replace them with a single 130 ohm resistor. So these are gone. And then finally, the 110 and the 130, now what term describes their wiring? I hope you're seeing series. Now that I've made all these guys go away, all I got is this. Whatever current enters and exits the 110 enters and exits the 130. So I now have an equivalent resistance of 240 ohms. This guy's gone and this guy's gone. 240. So that's it. The battery, he cannot see the resistors attached to him, but he can feel them. He's like that incredibly empathetic blind girl that you sometimes see in TV shows, where she can't see, but she feels, oh yes, she feels. And so you got equivalent resistance of 240 ohms. So here comes the next part. 24 volt battery, 240 ohm resistor. Tell me, what's the current out of the battery? Good, 10, except not 10, but that's okay. What is it? I mean, you were right, except it's wrong. Was that? Yeah, 0.1. right? Because if you do V equals IR, I got a 24 volt battery equals the current times the equivalent resistance, which is 240 ohms, and yeah, I got 0.1 amps. Okay, but your heart was in the right place, and that's all that matters. Okay? So once you get the current out of the battery, you can answer any other crazy question they ask. To answer parts C and D, I'm actually going to redraw the circuit, because I get kind of confused when I see all those resistors crossed out. Okay, here comes the part that kind of resembles Sudoku. What is that in the game with the numbers? What's that called? Sudoku? Sudoku. Okay, where you're going to use V equals IR to just work your way around this circuit. So let's consider right here, this is 0.1 amps. I have 0.1 amps of current going through a 110 ohm resistor. So tell me, what's the voltage drop across this resistor? That is, how much energy is that 0.1 amps of current losing? Or how much work is that 0.1 amps of current doing? What's that? How'd you get 11? Sure. Are you guys okay with that? V equals IR, right? V equals IR. I got a 0.1 amp current, 110 ohm resistor. That makes 11 volts. Okay? So here's the way you need to think of it. The negative terminal of the battery is at 0 volts. The positive terminal of this 24 volt battery is at 24 volts. So every coulomb of charge has the capacity to do 24 joules of work for you. Well, this charge is going to pass through this resistor and do 11 joules of work. It's going to lose 11 joules per coulomb of its energy, correct? So if your charge started with 24 volts, how much is going to end with at point A? Hope you guys are getting 13. Don't mess up. Don't put as the answer voltage from A to B. Don't put 11, because it's not 11. You started with 24, you lost 11. This is 13 volts. And the voltage at B, what's the voltage at point B? 0. It's connected via a conductor, and there's no voltage change on any point of a conductor. So this would be 0 volts. So I hope you see that the voltage from A to B is 13 volts. Now, here comes the tricky part. I need to get the current through the 250 ohm resistor. I want to get the current through that resistor. Nobody in either class could really figure it out. Tell me, can anyone here figure out, how do I get the current through the 250? Yes, Noel.
Are you going to find the voltage drop across the 180? Or not the voltage drop, like the current that the 180 needs?
Okay.
And then, because from the 13 volts, it's going to branch off down to the B, and also across the way you're drawn first. So do you need to solve for the B part? Like, do you need to solve for the current between A to B and then do the other part, because you're not using all the current on the outside?
Oh, okay, do you want to do that? Do you want to find the current passing through the 180 ohm? Okay, how do I do that?
You're going to do the V equals IR.
Thank you. You guys okay with that? I'm going to get this current. I'm going to do V equals IR, okay? The voltage drop across the 180 ohm is 13 volts. I don't know what the current is, but I know the resistance is 180 ohms. And so I get a current of, here, let me get my little calculator. Divided by 180, so I get 0.072 amps. Okay, so I just found the current here, 0.072 amps. Okay, but that's not answering my question. And someone besides Noel tell me, I found this current is 0.072 amps. But that's not answering the question. I want the current to this guy. How am I going to get that? Yes, Fatima.
Can you subtract that current from the point 1 to find the current that goes to the 220?
What do you guys think? Can I do that? Can I subtract this from that to get what that is?
Yeah.
Absolutely. Sure. So you make the subtraction. This is 0.1 minus 0.072, and I end up with 0.028 amps. And that current is going through the 220 and it's going through the 250, 0.028 amps. You guys okay with that? Was there another way I could do this that was kind of easier? Yes, Gavin?
Yeah, you could have just done, you could have added those two ohms in series to get 470.
Yes.
Then do V equals IR with the 13 volts drop you get, and that would get you the 0.28.
Well, Gavin, you're the only person in all 3 classes who actually figured that out. Good for you. Good. And everybody who watches this video will know it was Gavin. You guys okay with that? Why do that roundabout way? Why not just do V equals IR? I've got a 13 volt drop across the 2 resistors. I've got 470 ohms with those 2 resistors, and I do clear 13 divided by 470, and I end up with a 0.028 amps. You know, just do that. But here's the thing, if this were an exam, would I care which method you used?
No.
Heck no. I just want right answers. I don't care how you do it, just as long as you do it right. But there's a ton of right ways to do it, you know? Okay, any questions or problems on this? The other way to do it, which is actually not really possible, if you could get the voltage drop across the 250 alone, you could do V equals IR. But the problem is you can't really get that voltage drop without knowing the current first. So really Gavin's way is the only way to do it, the quick way. Okay, hey, it's time for you guys to do a problem. Here it comes. Here comes your problem. Hey man, that's not my problem, that's your problem.
Right.
Okay. This is a 25 volt battery. This is a 20 ohm resistor. This is a 10 ohm resistor. This is a 60 ohm resistor, another 60 ohm resistor, and then this is a 20 ohm resistor, and this is a 40 ohm resistor. All right. And you're going to get the following. I need to get the equivalent resistance. I need to get the current out of the battery. I need to get the voltage drop from A to B, where this is A and this is B. Okay? And then finally, I want you to get the current in the 40 ohm resistor. Good luck, you guys. And I will walk around and help you. In quotes, I just let me say it. I'm going to walk around and help them. Because usually I don't help, I just yell at them and say stupid things. Do you think you have to draw that thing first before you start working on it? Well, you better believe it. If I don't see a schematic on your exam, I'll just give you an F. Even if you're Zach Jensen. F.
You should give Gavin an F too.
What did I do?
F for Gavin.
What did I do? What am I even thinking?
Oh, Gavin.
Just what it sounded like.
See, this is why we give you an F.
What did I do good?
Oh no. It's stuck again.
Close it out. No, like actually. I Voltage drop.
Cold is
Why is he absent so much?
I don't know. It's a good question. Let's see what we got. What'd you get for the equivalent resistance? Here's the thing. You got these two guys being 60, right? And I got 60, 60, and 60 in parallel. You should be getting 20. 3 60s in parallel, you divide by 3, you should have 20. So something went wrong here, you know? Because this is, yeah, you can't do 120. Like 2 60s in parallel isn't 120, 2 60s in parallel is 30. So if you'd have done 60 with 30, then you would have gotten the right
You need
answer
to
there.
figure out how much.
Everything else you're doing is right there.
Yeah, so I did 60.
Let's see what you get for the equivalent. Yeah, you're correct. Good for you.
Resistor, like you see the 110.
What'd you get for the equivalent?
11, so that's why you did 24 minus 11, and that's how you got the
Okay,
voltage
good.
drop between.
All the way,
So
by
to
the
find
way,
voltage
I
drop, you
wouldn't
have
want
to
you to be
find
faster. I want you to go 60, 60, 60. Okay, that's 3 identical resistors. Parallel, just divide by 3.
Full and driving, then you do V equals IR.
You don't have to do the resistance formula for that.
Okay.
Can I see? So here's the thing, you got 60, 60, 60. 3 60s in parallel is 20. You know, 60 divided by 3 is 20. So but you're kind of doing some freaky thing where you did a 60 with a 60 to get a 30, but then you should do 30 with 60. So if that was a 60 there, 30 with 60, you would have had the right answer. But why not just do the first one? Do you get the equivalent resistance?
Oh, because
You
it's
got
like
60, 60, 60, right?
resistances
And they're in
are
parallel?
they're similar.
360s in parallel is
You just
20.
take the
So, yes, you're not parallel with these guys. Your 60
Yeah,
is not
it was,
parallel
our-
with 20. It's not parallel with 40. Your 20 and 40 are series. You should combine them first.
Answer's 50.
Plus
Yeah.
Great.
Current through the tube ring.
Wait, that's what you have so far is great. Now you got 20 and 10.
So that's 80, so,
You get the equivalent resistance?
yeah, because they're in, what's called series, so then that's
Down.
Mine are
Yay. Yay. Good for you. It's always funny that people who have that getting it done. That's
The
not
only one I don't
correct.
think is right.
Yeah, because you're starting at 25. Here's the thing, you're starting at 25, and then 25 and
Yeah,
25.
so is it just 12.5 as the drop?
Yeah, so you're starting at 25, and you're starting at
Oh, wait, no,
Oh,
this
okay,
is
so it's
one.
just
Yeah, that's what you gotta think about.
Well, you might have been right.
whatever helps you.
Oh my God, good for you, Lily, wow. Don't have to say anything to Lily. Good for you, your equivalent resistance is correct. What do you got? Good. Also, 360s in parallel is 20. If you have 3 identical resistors in parallel, the equivalent resistance will be 1/3 of what each individual is. Great, good for you. Excellent.
So did you get,
Oh, you're oh so smart. I'm in a smart carbon classroom.
for the,
Good, everything you have
oh,
is
the voltage?
correct.
But isn't it 0.5, so because you start with 25 volts, it has to do the 2 resistors, so then after there's,
Did you get
there's
this?
30.
Did you get 60, 60, 60 in parallel and 20? No, it's not 180. It's 60, 60, and 60. 360 in parallel is 60.
Of course, I never expected you to be an encourager of fighting.
Seems like a nice change.
Yeah, now you gotta add that and that. They'll be series resistors.
Yes.
So you get the equivalent resistance. Yeah, okay. Oh, let me check it.
So that's 6.
Yeah.
Because for the last one, it's like there wasn't that.
Wait, are you done too?
Oh, yeah, no.
This is 60, right? Don't you have 60, 60, 60, and
Then you find
So, we haven't talked to her yet, but I'm assuming what she's thinking is that if other people want to build, and if people want, because for sure we're only focusing on one event each to protect them out of them. And so I'm assuming she's thinking is if other people want to build everything, who still want to do so,
That's where you're
do those other events that they want to do, and then
Stanley, keep your head close to your head, thank you. You're good.
No, we would, me and Mara would build it, so this way, and Milani and she could
I don't have
You know, we brought the 7 broadband, we broke all of them.
so you have 25.
you guys need a lot of help. You guys are good. You guys just do so many areas in between.
So now you have 5.
No. Yes, wait, yeah.
Do that first 20 and
No,
60.
60.
Because I remember
Oh, you're right, you're right. Voltage block, yeah, here it is.
That's the because it's connected in series, so I just want to.
Okay, guys.
yes, because I
I could be wrong.
Samara Meyer was testing it, and it wasn't a bad helicopter.
Are we ready,
Samara was
Imani?
testing it, and it wasn't a bad
Oh,
helicopter.
no.
Yeah.
See it?
Okay. Hey,
It wasn't a bad
let me get everyone's attention. Let's go ahead and do this. Oh, here, I'll stand in front of the camera. Let's go ahead and do this. First of all, virtually everybody here recognized this was 60, okay? And so now I've got 60, 60, 60 in parallel with each other. And so I would want you to go 60 to the -1 plus 60 to the -1 plus 60 to the -1 to the -1. That would be fine. But better still, I need you to really have in your head the 3 identical resistors in parallel. The equivalent resistance is going to be 1/3 of any of those individual resistors. But if you want to do that, if you want to waste time, that's fine with me. But I'd really, if I told you I had 3, let's say I told you I had 4 100 ohm resistors in parallel. What's the equivalent resistance? 25. Yeah, I don't want you to have to do that. But if you want to do it, that's okay with me. But I just want you to get used to the fact that n identical resistors R in parallel is R over n. So anyway, that's 20. Then I got 20 plus 10 plus 20, which makes a grand total of 50 ohms. Any question or problem on that the equivalent resistance is 50? Okay, then the current out of the battery, I'm a 25 volt battery. There's 50 ohms across my terminals. That's 0.5 amps. That's the current out of the battery. Once you got the current out of the battery, you can answer any of their crazy questions by doing the Sudoku thing. Here, this is 0.5 amps. I hope you see that 0.5 amps to a 20 ohm resistor is a 10 volt drop. Which means if your charge started with 25 volts of electric potential, it just lost 10 of it here. So now you're down to 15. And then 0.5 amps, 10 ohms, 5 volt drop, and that puts you down to 10. And that's really the way I want you to do this. So the voltage from A to B is 10 volts. Any question or problem on the voltage from A to B? Yes?
So you can just add the 2 resistors and then just
That's what I tried.
yeah, and then multiply it times the amps and then subtract it from the original voltage.
Yes, sure. Chris said, Mr. Shana, maybe I don't want to do it the way you did it. Can't I just add those 2 resistors, multiply 0.5 times 15, get 15, you get 0.5 times 30, get 15, and subtract the 15 from 25 to get 10? And the answer is yes. Sure. And now it's time to get the current through the 40 ohm resistor. Someone tell me, how did you do that? Yes, Alejandro.
You took the voltage left over, the 10 volts, and then you did V equals IR, and your resistance is the 2 resistors in series, so you add MOSFETs.
Beautiful, you guys okay with that? If I got a voltage drop of 10 there, I have a voltage drop of 10 there, because this point is attached to that point via a conductor, and this point is attached to that point via a conductor. So yeah, all I have to do is 10 volts over 60 ohms, and I get my 1/6 of an amp. Here's another way to do it though. I've got 0.5 amps here, correct? And do you see the 0.5 amps is being split between these three tributaries? And do you see that each of those resistances are identical? So this idea of current seeking the path of least resistance, well, they're all equal. They're the same resistance. So what's going to happen to that current? Yeah, it's going to be split into three, right? So each of these currents is going to be 1/3 of the 1/2 amp, which gets me 1/6 of an amp. Did anyone do it that way? Because you could have if you wanted to. Okay. Yes.
So you don't have to worry about the second 60 with the,
You mean this guy?
yeah, when you're finding the current for 40.
No, you don't. All that matters is the voltage drop from there to there and the voltage drop from there to there. Sure, it's the same as that voltage, which is the same as that voltage, and that's okay. But anything happening here isn't going to affect this. His voltage drop is 10 no matter what these guys do, because that's 10 and that's 0. Yeah. Anything else? All right, then hey, I'm done. And tonight's homework is going to be just a lot of this stuff. So good luck. And at this point I say bye-bye.